Hi, and welcome to MSc. In this video, we're going to look at simplifying radicals. So before we can begin on this, we should look at what a radical is and identify the different parts of it. So you're probably used to the radical in what is typically the square root form. And so we have here the actual radical symbol. That also is the same as the symbol here. You'll notice here though that we have this, which makes this a cube root, which you probably have seen in different problems when working with cubes, for example. This can be called the index, or sometimes called the principal root. And when there's nothing written there, then we assume that it's a 2. And we call it the square root. Underneath the radical symbol, we have what's called the radicand. And that's the same in both of these. These are referred to collectively as the radicand. So the square root, to refresh your memory, looks at which number times itself, because there's 2, so times itself, will generate 25. And in this case, the answer would be 5, right? 5 times 5 would be 25. Here with the cube root, it's looking for what number times itself 3 times would equal 27. And in this case, that will equal 3, because 3 times 3 is 9, times another 3 is 27. So cube roots and square roots and other roots will always do that same type of method all the way through. So let's look at applying some of this to simplifying radicals. So to simplify a radical, we need to look for factors in the radicands that are perfect squares. So we have to remember what the perfect squares are. Well, we know that 4 is a perfect square because it's 2 times 2. We know that 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, so forth all the way up. When we're working at this level, we're typically working with square roots, although we could work with cube roots in some scenarios. So when we're trying to break this one down to simplify it, we're going to look for one of our perfect squares that is a factor in this 150. So you might say that 25 is going to go into the 150, which is completely correct. So let's look at this. It's going to be 25. It'll be 25 times what? Well, it'll be 25 times 6 would be 150. So we can write it like this, and we can also then write it as root 25 times root 6. And then we know what root 25 is. It's 5. So now I've listed this as this mixed radical, right, where I have this whole number as a coefficient and I have my radical. I cannot simplify this any further now unless I convert to a decimal equivalent, and at that point it would be an approximation. And writing it in this way is an exact term. Let's look over here, 320. So you can see as the numbers get a little bit larger, this can be a little bit more challenging to do, right? And so you'll need to know, I would say, your perfect squares at least up to 12, maybe even a little bit higher would be useful for some of these activities. But remember, kind of like simplifying fractions, you don't have to go straight to the answer. So you could look at this and say, well, look, I don't know maybe the biggest factor that's going to go into this, but I know that 4 is going to go into it. I see the 32, and I think 4 is going to go in. So if I did this, I could say, well, this is going to be root 4 times root 80. Right? And I've gone straight to this step, not writing it all under one radical symbol. And I know that root 4 is 2. So it's going to be 2 root 80. But then you should always look and see, can you simplify this further? Well, I certainly can. There's another perfect square that's in there. I can see, well, there's another root 4. So there's another root 4 in there. And now it's going to be root 20. And root 4 is 2. So 2 times 2, root 20, which would be 4 root 20. And you might say, well, I'm done now, but then you can look at the 20 and realize, oh no, I can actually reduce that because there's another factor of 4 hidden in there. So root 20 can be root 4 times root 5. And as we've established, root 4 is just 2 times root 5, and this will be 8 root 5. I can no longer simplify this any further. So the math in each step wasn't challenging. Because we didn't notice a bigger factor right away, we had to do multiple steps. So as you practice this skill, and as you get better at seeing these perfect squares as factors of the radicand, it'll make your life a little bit quicker. Because maybe I'd look at this and I might have said, well, wait a second. I see, with a little bit of thought, that there's actually 5 64s in that. 64 times 5 is 320. And root 64 is 8. Now, seeing that right away takes a little bit of work, a little bit of practice, and maybe you wouldn't even get there. You don't need to, but you can tell it takes a little bit longer if you don't see that largest one at the beginning. But just like fractions, that's not a problem. Take your time. With practice, you'll be able to spot larger and larger perfect squares as factors of the radicand to help reduce these radicals. I hope you found this short video helpful about simplifying radicals. Please check out the subsequent videos I have about adding and subtracting radicals, as well as multiplying and dividing radicals. Thanks very much for listening and watching. Please consider to like and subscribe.